Let's start simple. Think about money today. Most of it isn't physical cash, it's digital, existing as numbers on computer screens. This digital money is primarily controlled by banks and governments who oversee the financial systems. They have the power to freeze accounts, print more money, potentially causing inflation, and track every financial move you make. Now, imagine a form of digital money that isn't controlled by any single entity. A system with no banks acting as intermediaries and no governments dictating its rules. That's the basic idea behind cryptocurrency. It operates on a groundbreaking technology called blockchain. Think of blockchain as a public, incredibly secure digital ledger. This ledger isn't stored in one place. It's shared and constantly updated across thousands of computers worldwide. Every single transaction made with the cryptocurrency is permanently recorded in this shared ledger, making it extremely difficult, bordering on impossible, to cheat the system, tamper with records, or alter the transaction history. Cryptocurrencies like Bitcoin and Ethereum empower you to send value directly to anyone, anywhere in the world, without needing to rely on a bank or other financial middleman. It's similar to sending an email, but instead of sending a message, you're sending money or other forms of digital value. This decentralized system gives individuals greater control and autonomy over their own finances, offering particular benefits to those who are unbanked or underbanked, who lack easy access to traditional financial institutions. But here's the catch. Maintaining the security and integrity of this global decentralized ledger requires a massive amount of computing power. All those computers that are constantly verifying transactions and maintaining the blockchain need electricity, lots and lots of it. The complex process of adding new transaction blocks to the blockchain and ensuring that everything remains secure and tamper-proof is inherently energy-hungry. And that's precisely where the environmental concerns surrounding cryptocurrency come into play. The very characteristic that makes cryptocurrency such a revolutionary technology also presents a significant challenge and a potentially big problem for the health of our planet. So how exactly does this digital money actually work behind the scenes? And what are the underlying reasons that it consumes such a substantial amount of energy? The big issue with crypto, especially Bitcoin, is energy consumption. Massive networks of specialized computers run non-stop, solving complex puzzles to keep the system secure. This uses more electricity than some entire countries. The real concern is where that energy comes from, often fossil fuels which drive climate change. Some mining operations even revive old coal plants just to power their computers. As crypto grows, so does its energy demand and environmental impact. It's not just a tech problem. It's a real-world issue with measurable consequences. The way cryptocurrencies are designed ties them directly to energy use. To understand why, we need to look at how these systems actually work. The engine driving crypto's energy consumption is a process called mining. It's a fundamental aspect of how many cryptocurrencies like Bitcoin maintain their security and validate transactions. This process is powered by a mechanism known as proof of work. In this system, miners engage in a fierce competition, all striving to solve complex computational puzzles. The miner who successfully solves the puzzle first gets the privilege of adding a new block of transactions to the blockchain. As a reward for their efforts, they earn newly minted coins. This competition isn't confined to a single location, it's a global guessing game, happening simultaneously across the world. And it's not just a simple guessing game, it's one that requires trillions of guesses per second, pushing computing power to its absolute limits. As the number of miners increases, the puzzle's difficulty automatically adjusts, ensuring that it remains challenging and competitive. This constant race to solve increasingly complex puzzles means that more and more energy is burned in the process. This brute force approach, while energy-intensive, is the very foundation of the network's security. To successfully cheat the system, an attacker would need to amass and control a majority of the world's mining power, a feat that's incredibly difficult and expensive. But this robust security comes at a significant energy cost, raising concerns about sustainability. The system is intentionally designed to be inefficient, making attacks prohibitively expensive and thus deterring malicious actors. Therefore, energy use isn't just an unfortunate side effect, it's a core component of the proof-of-work mechanism. It's not an accident, it's built directly into the design of the cryptocurrency's infrastructure. As the value of cryptocurrencies rises, so too does the incentive for miners to invest in more powerful hardware and consume even more power. This escalating energy consumption is precisely why Bitcoin's environmental impact is such a hotly debated and controversial topic. The big question is there a more sustainable and environmentally friendly way to secure digital money without burning through so much energy? Is crypto uniquely bad for the environment? This is a question that sparks a lot of discussion. Or is the whole financial system, as it currently exists, inherently energy-hungry? Perhaps the focus shouldn't be solely on crypto, but on the broader implications of how we manage our finances. Traditional banking uses energy too, a significant amount in fact. Just think of the energy consumed by bank branches, ATMs, which are operational 24/7, data centers humming with activity, and the constant need for transporting physical cash across vast distances. Let's not forget that gold mining is also incredibly energy-intensive, requiring massive machinery and resources, and it's undeniably environmentally destructive, leaving behind scarred landscapes and polluted ecosystems. Comparing the energy use of these different systems is tricky and complex, with many factors at play. Banking's environmental footprint is spread out across countless locations and operations, making it notoriously hard to accurately measure its total impact. While Bitcoin's energy consumption is relatively transparent thanks to the nature of the blockchain. This transparency makes it easier to track and analyze its energy usage patterns. But there's a key difference to consider when evaluating these systems. The energy consumption of traditional banking and gold mining generally scales directly with the level of activity, whereas Bitcoin's energy use is primarily tied to its price and the security of the network, and not directly correlated to the number of transactions processed on the blockchain. One block on the blockchain could contain a single transaction or millions of transactions, but the energy cost for mining that block remains essentially the same, regardless of the transaction volume. This fundamental difference makes direct comparisons between these systems particularly tough and often misleading, and it inevitably fuels the ongoing debate about the environmental impact of cryptocurrencies. So, the real question we should be asking is, which system, in the long run, is truly more efficient, sustainable, and environmentally responsible? Crypto's energy use is visible and under increasing scrutiny, but the old, established systems aren't exactly paragons of green practices either. The debate surrounding this complex issue is far from settled, and requires a more nuanced understanding of all the factors involved. Not all cryptocurrencies are created equal. Bitcoin is just one example. Thousands of other cryptos use different, much more energy-efficient technologies. Many new projects were designed to avoid Bitcoin's energy problems from the start. The crypto world is diverse, with coins for smart contracts, payments, and more. It's wrong to lump all crypto together as environmental villains. Also, not all mining uses dirty energy. Some operations use renewables or even waste energy. Miners chase the cheapest power, and renewables are getting cheaper. The industry is adapting, with more mining moving to cleaner sources. Crypto's energy mix is changing, and greener alternatives are gaining ground. The future of crypto doesn't have to be tied to fossil fuels. The solution? Proof of stake, a greener way to secure crypto. Instead of burning energy, validators stake their coins as collateral to process transactions. Honest validators earn rewards, cheaters lose their stake. No energy-intensive puzzles, just a competition of capital, not computing power. The energy savings are massive. Ethereum's switch to proof of stake cut its energy use by over 99%. This proves big networks can go green without sacrificing security. Most new cryptos now use proof of stake or similar low-energy systems. As users, we can choose to support these sustainable options. Crypto's environmental story isn't set in stone. The tools for a greener future are already here. Innovation and sustainability can go hand in hand.